Greetings to all of you. In today's session, we are going to discuss about the intermediate or plus two chemistry level, where the international chemistry, any competitive exams or entrance examinations, India level, JEE advanced and JEE mains examination, NEET chemistry, Telangana EAMCET and Andhra Pradesh EAMCET examination point of view, the topics are going to be discussed. In order to explain, we collected all the previous year question papers and a detailed explanation is provided. Hope this session will be helpful for your preparation towards to achieve whatever you are aspiring for. Let's enter into our question number 1. The diagram shows the experiment to demonstrate the diffusion process. This is the closed container. Cork is fitted in two ends of the glass tube, and here we have the cotton cork which is soaked into the hydrochloric acid in the one end, and second cotton wool soaked into ammonia solution in the another end. Here hydrochloric acid having the process of diffusion, ammonia is also having tendency to diffuse, move along this glass tube. Okay, so whenever this movement is observed, so here the formation of product we can notice, that is called ammonium chloride. This is a process of experiment provided over here, and the question regarding this experiment is, which statement explains why the ring of ammonium chloride appears as shown? So in general, whenever two reactants are going to be treated, you have to get the product at this position, right? Rather, it is generated somewhat near to hydrochloric acid and away from ammonia solution. The ring is generated that belongs to the product, ammonium chloride. Now we have to find what could be the answer regarding this. Ammonia solution only produces the gas, which moves until it meets to the hydrochloric acid. Here, vaporization of ammonia only possible but not hydrochloric acid. They are saying like this, but this is not the correct answer. Both the solutions produce the gases, but ammonia moves quicker than the hydrogen chloride because it is lighter. This is the correct answer with regarding to the experiment provided. Okay, hydrochloric acid can be vaporized. Ammonia also vaporized into the gaseous one. Whenever both the gases are vaporized, so when they are moving, their speed also matters here. The speed depends upon their molecular weight. Molecular weight of ammonia and hydrochloric acid taken into the consideration. Obviously, ammonia is light in weight, that's why move quickly so that it will run very fastly towards the hydrochloric acid. Hence, we can find that the product is near to the hydrochloric acid, being hydrochloric acid running slowly. So that lightweight ammonia is quicker in its movement, so that we will get the product near to hydrochloric acid. We can find, so this can be explained in according to their molecular weights. If you see molecular weight of hydrochloric acid, that will be taken as 36.4. Ammonia molecular weight is given as, here 14 is a 7 is the atomic number, 14 is the atomic mass of the nitrogen, and 1 is carded for hydrogen. In such a way, we have 3 hydrogen atoms. So that let me add 3 hydrogens over here. 14 plus 3, it will become 17. So almost double molecular weight is accorded for hydrochloric acid, so that moment of hydrochloric acid is somewhat slower. We can notice the formation of ammonium chloride near to hydrochloric acid. Quicker the movement for ammonia because diffusion rate will be higher for ammonia molecule, being it is lighter. Move on to question number 2. When smoke particles are observed with the microscope, they are seen to move around randomly. Whenever smoke particles are present in the air, we can't see them, but when you observe under microscope, we can see them, but they are moving very randomly, random movement without any particular path. They are running, they are hitting themselves, and this is a random zigzag motion, is regarded as a Brownian motion. And what actually causes this Brownian movement? What causes Brownian motion? There are 4 options. Diffusion of the smoke particles. If so, smoke particles are diffusing so that the Brownian movement is observed, this might not be a correct one. Molecules in the air hitting the smoke particles, hitting of molecule, collisions are possible. Sublimation of the smoke particles. Sublimation denotes what? Direct conversion of solid to gaseous without the liquid phase is called a sublimation. That can't be a correct answer. Small particles hitting on the walls of container. right? So whenever smoke particles are taken into the consideration in a closed vessel, these smoke particles having tendency to move, run fastly, but they are going to hit on the surface of walls of that container in which they are filled. So that random movement is accorded. Its path will be immediately changes. There are two type of collisions we can notice: the particle-particle collision as well as particle with the walls of the container collision. Both are immediately changes the path of that particular, so that random motion we can notice, and that is the actual reason for this Brownian motion. Let's go with the question number 3. The percentage of nitrogen in the uracil is the heterocyclic compound containing lactam rings in this, and it is the biomolecule. Uracil is a kind of cyclic amino peptide, cyclic peptide we can say. So here NHC double bond is present, cyclic lactam it will be. Here two nitrogens are there, percentage of nitrogen to be depicted. In order to get the nitrogen percentage, the formula will be percentage of nitrogen is equal to atomic weight of nitrogen by total molecular weight of the uracil into 100. Here, if you see the molecule, you can find two nitrogen atoms. Each nitrogen atomic number 7, atomic weight 14, two nitrogen, so that you can accord 28 is the weight of nitrogen, and overall molecular weight of uracil, just take the sum of all the atomic weight so that you can get 112 grams. 28 is the nitrogen, 112 uracil molecular weight, and being percentage can be contributed with the multiplication of 100 factor. So that 28 by 112 can be multiplied with 100, so that we will get 25 percentage. The nitrogen percentage in this molecule of uracil is 25 percentage. Let's go with the question number 4. Which oxo acid can reduce silver nitrate, right? So oxo acids are given, all are the oxo acids of phosphorus itself, and among these many oxo acids of phosphorus, which is selectively reduces silver nitrate to be depicted, and the answer will be H4P2O5. It is the dimer of phosphoric acid. So in this, how can we distinguish which is able to reduce the silver nitrate? There is a key factor that will be to reduce the silver nitrate, oxo acid should behave like a reducing agent. In order to reduce, it should be in the lower oxidation state around the central phosphorus. Highest oxidation state of the central phosphorus will be +5. Less than +5, if you observe anywhere, that will be the better reducing agent. That is only the right key term we need to depict, so that it is obvious to get the answer which is going to reduce the silver nitrate solution, right? If you go with the polymeric HPO3, when HPO3 was taken, this is called metaphosphoric acid, where you can find two oxygens are bonded with a double bond, contribute -4 charge, OH obviously will give -1. Total negative charge is -5, so that phosphorus will accompanied by +5. Central oxygen is accompanied by +5 oxidation state. It is the highest one, so that it will not contribute reducing agent. Go with the compound number 2, B option, H4P2O7, called pyrophosphoric acid. The pyrophosphoric acid is a dimer, where you can notice the pyrophosphoric acid. Here, phosphorus accompanied by oxygen, OH, and ether linkage over there, right? So let's find out what could be the oxidation state of this phosphorus over here. Two phosphorus are symmetrically bonded. Symmetrically means both are having equal environment. Let's count. Double bonded oxygen will contribute -2 charge. Ether linkage also contribute -2 charge. So 4, 5, 6, 7, 8, 9, 10. Total negative charge contributed by the oxygens are 10. So 10 negative charges, so that 10 positive charges will be there. 10 positive charges shared between the two phosphorus, so the 10 by 2, we will get each phosphorus +5 charge, so that +5 is the highest oxidation state for the central phosphorus. So it is also not possible to get reduced silver nitrate. Let's go with another compound called H4P2O5. If you see this compound, Here you can find compared to pyrophosphoric acid, pyrophosphorus acid is having more two hydrogens less. That's why its oxidation state around the central phosphorus will be reduced, and being it is asymmetrical, two phosphorus equally accorded with the oxidation states around the central phosphorus atoms. Let's see. Oxygens double bonded will contribute -2, so that -2 for double bonded O, -2 for double bonded O, 4 plus ether oxygen also -2, 6 OH1 OH1 7 8, total negative charge 2 4 5 6 7 8, total negative charge is accorded for uh, two phosphorus atoms will be +8, and what we will do, +8 can be taken with the two phosphorus, so that +8 by 2 +4 will be accorded, so that less than the actual oxidation state +5 is accorded. We can say it is the actual reducing agent over here. Pyrophosphorus acid is the correct answer, because less than its highest oxidation state is available in this compound only. So whatever another option given, let's see this. H3PO4 is called orthophosphoric acid, where double bond O is -2, 2, 1, 1, 1. Total -5 charge for oxygen, so that phosphorus, central phosphorus is accompanied by +5 oxidation state. Again, it is the highest oxidation state for the phosphorus. So that correct option will be option number C only, where you can notice the lesser oxidation state around the central phosphorus. Then only reducing agent. It working like a reducing agent for silver nitrate. So right option will be C for question number 4. Let's move on to question number 5. It is a question given from electrochemistry, where the cell containing ceric +4 and ceric +3 charges are given. Cerium +4, cerium +3, where this is the kind of reaction giving rise 1.6 volts of current, and iron +3 and iron +2 is giving 0.76 volts of E0. Standard electrode potential values are provided. Two electrodes. This is called one electrode, and this is also called another electrode. We need to depict which will be a cathode, which will be a anode electrode over here, right? And finally, E0 of the iron oxidizing cerium +3 is E0 value to be produced. In order to get that one, these many options are provided. Among all, -0.84 volts will be the correct answer. For that, the formula is electromotive force is given by E cathode minus E anode, which is taken as 0.76 minus 1.6. Iron minus cerium, right? 0.76 minus 1.6 volts, so that it will become -0.84 volts. So this is the way we can solve this electrochemistry problem. Let's move on to question number 6. Assertion and reasoning question is given over here. In aqueous solution, amino acid exists in dipolar ion form. Dipolar ion in the sense, one end having partial positive, in either end is having partial negative charges. In the single compound is called a dipolar. Poles are nothing but positive pole and a negative pole, right? If the single compound is having dipolar, that is called amphoteric in nature. Aqueous solution amino acid exists in dipolar ion form is the assertion. And reason is most of the naturally occurring amino acids have L configuration. DL configuration is the rightist representation of the active functional groups and the chiral carbon atom. Right. So let's see whether assertion and reasoning both are exactly correct answers, correct options given. Reason is mapping with this assertion or not. For that purpose, let's go with the answers. A is true. R is also true. R is the correct explanation of A. A is true. R is also true, but R is not correct explanation for A. So this is the correct answer. Whatever assertion is given, always amino acid when dissolved in water is a dipolar ion is the correct answer only. Whenever naturally occurring amino acids are considered, all are in L configuration. This is also correct. Both the statements, whatever provided around the centrality of this nature is correct, but assertion will not be properly justified by the reason whichever allocated here. That's why A is correct, R is also correct, but R is not a correct explanation for A. Let's see what is the explanation. What is meant by dipolar ion? Whenever amino acid stands for the compound having amino and acid both in the single one is called amino acid. It is the starting material for the protein synthesis. Whatever proteins we have, all these proteins are bounded. All these proteins are synthesized from starting material called amino acid. Whenever the amino acid added to water, the natural tendency of acid to lose the H plus and natural tendency of base to accept the H plus, so that you can find NH3 positive, COO negative. Existence of the single compound in a dipolar form in an aqueous solution is called a Zwitter ion. Because of this Zwitter ion formation in the amino acid, we can say amino acids are amphoteric in nature because proton donor and proton acceptor, right? In accordance with the Bronsted, here acidic and basic nature both are accorded. Hence, we can say the compound is amphoteric in nature. And another, the compound amino acids, if contains NH2, active compound and on the chiral center, and the right hand direction is called D amino acid, left hand direction is called L amino acid. Always in the nature, amino acid always found in L amino acid. The configuration is accorded as a L amino acid, but not D amino acid. Okay, all the carbohydrates, sorry, not all, most of the carbohydrates are deconfigurated. Most of the amino acids are L configurated, right? So that's the reason why here A is correct, R is also correct, but R is not correct explanation for A. Both are not justifiable, right? By this, we completed the session. All the questions, whatever segregated, got properly answered. Hope this session will be helpful for your aspirational preparation. And I am requesting you to like the channel, comment for any queries if you have, and share this content with the aspirants whoever preparing seriously for the examinations, and subscribe the channel for more updates. Further videos can be given for you. And thank you very much for your patient listening. Thank you one and all.